as an introduction, we are going to link the concept of limits to derivatives. There are some limit expression that cannot be performed using the properties of limits. We need to approach it using some strategy that we will learn in this module, so that first we have to identify what are these forms of limit that requires this kind of strategy. Say for example, we want to compute the limit of the function x over x squared minus 9. This is when as x approaches infinity. Now, when you are going to plug in x equals infinity, you will have this notation infinity over infinity, because this will be replaced with infinity and this will be replaced with infinity squared minus 9, which is actually also infinity. However, we have what we previously learned na if our argument approaches infinity, such as this one, we can divide all terms by the x squared. So we have 1 over x. Divide this by x squared. So we have 1 minus 9. And so 9, that gives us 8. The numerator is 1 over infinity, which means that if you still recall, a constant divided by infinity approaches the value of 0. So this means the answer for this limit is 0. Okay? If you plug in the value of infinity without that approach, that would be infinity over infinity. So remember that if you have that kind of form, infinity over infinity, 0 over 0, we have also infinity times 0, infinity minus infinity, 0 raised to infinity, 1 raised to infinity, and infinity raised to 0. These are what we call indeterminate forms. So what are we going to do if we encounter this? We have a theorem that states that the limit of f of x over g of x as x approaches 0 is equal to the limit of the first derivative of f of x over the first derivative of g of x as x approaches 0. And that is what we call L Hupitas Rule. What happens now if you encounter 0 over 0 or infinity over infinity? That is what you're going to do, but with a condition. F and G should be differentiable on I. The G prime is never 0 on I, except maybe at F of or G of A. Then the limit as f of x divided by g of x as x approaches a is equal to this one. So this is what we're going to use for indeterminate forms. It has to be, remember, of 0 over 0 or infinity over infinity. So let's have it continuation with our discussion. Suppose we're trying to analyze the behavior of the function f of x equals ln of x over x minus 1. Although we know or we notice that this f of x is not defined when x is equal to 1, we need to know kung paano nagbe-behave as it approaches 1. So we would apply now the concept of limit. We will investigate how this function behaves as x approaches 1. So we have this expression, the limit of ln of x over x minus 1 as x approaches 1. Now, we cannot apply x to 1 because in this case, our denominator becomes 0. And ln of 1 is also 0. If you try in your calculator and press this value, you will take note this is 0 over 0. Isn't it? 0 over 0. Now, we can apply this one also to this particular function. But why do you need to apply LHR or L Hupitas Rule when you can actually apply the conventional approach? In this case, at first, when you look at this, you have 1 minus 1, which is equivalent to 0. This one also is 0, so this is of the form 0 over 0. However, you can still factor this. So when you do the factoring of the numerator and then the denominator, these two will cancel. So what's left is the limit of x over x plus 1 as x approaches 1. And you can immediately substitute the value of x without some restriction on the denominator. So the answer is straightforward. It is equal to 1/2. So there's no need to apply L Hupital's rule here because you still have other strategy na you can apply, such as factoring, right? So when it's not possible or when it is already you have already applied factoring and still it is 0 over 0, that's the time that you apply L Hupital's rule. Similarly, we also have an expression if you still, or if this was discussed to you in, I don't know with what topic, but this one is a property, which is, may proof ito, na hindi ko na maipakita dito, pero meron itong proof that the limit of sine of x over x, or the limit of sine alpha over alpha as alpha approaches 0 is actually equal to 1. We can, if we encounter limits with trigonometric functions, we can apply this one. Okay, we can apply this. We cannot say that this is 0 over 0 because, as I have said, there is a geometric argument to this that shows this is equal to 1. So we cannot make use of L Hupital's rule for this one. For our given na, di ba previously we have this expression na ln of x over x minus 1 as x approaches infinity. So what if we change the argument? We say ln of x over x minus 1 as x approaches infinity instead of 1. What will happen, class? What do you think will be the value? What is ln of infinity? What is the value of ln of x? As x becomes very, very large, what do you think? It approaches the value of? Let's say you start with ln of 100. What's the value? Then ln of 1,000. ln of 1 million. So ln of...
Positive infinity, ma'am?
It is infinity. Yes, correct. Now, what is the limit as x approaches infinity of x minus 1? What's the answer? Let's say 100 minus 1. 1,000 minus 1. 1 million minus 1. What's the value, class? What's the trend?
Infinity.
Huh? The answer is?
Infinity din po.
Infinity din. Wow, class, paano na yan? Ha? Just substitute yung mga values na pataas ng pataas and take note of the trend. Anong pattern? So, ibig sabihin, yung pattern habang tumataas ang nire-replace kong value kay x, nagiging mataas din yung resulting value nito. So, unbounded siya. Ibig sabihin, infinity pala siya. Ganun din dito. Kasi itong 1 na to, magiging irrelevant na siya. Dahil, yung x na yan ay palaki ng palaki. So, infinity din. Kaya, ang argument dyan, kung yung numerator ang mananalo, then we have a value of infinity. Pero kung denominator, halimbawa, infinity over infinity, kanina 0/0. Ngayon, infinity over infinity. So, hindi mo masabi, wala talaga siyang definite answer kung ganyan lang ang argument mo. Kasi pwedeng kung ito yung manalo, the answer would be infinity. Pero kung ito yung mananalo, then any number divided by infinity approaches 0. So, actually, hindi mo alam. So what you're going to do if you encounter this, the same with 0/0, you're going to apply the L Hupitas Rule. So in our previous module, we have, as I have illustrated a while ago, that if you have an argument that approaches infinity, what you're going to do is to divide all terms with the variable having the highest exponent. Divide that by 1/x² and so on. X². So what will happen here? This will be 1. This is 1/x², 2, because 2x² is 2, plus 1/x². If you apply infinity to x, any number divided by infinity is 0. The same with this. So therefore, we have a straightforward answer to this one. Okay? So okay yan if you have a straightforward answer, meaning nag-work itong strategy na to. Ano tong strategy na ito? Take note of this. I discussed this in module of limits. That if you have an argument that approaches infinity, you're going to divide all terms with the degree of the variable of the highest exponent. Now, for this expression, it works. If it works, then there's no need to apply for L Hupital's rule. But also, of course, we can apply L Hupital's para dito. Pwede rin naman. The L Hupital's rule work for this, pero gaya nga ng sabi ko, you only apply L Hupital's rule kung na-expose mo na yung mga possible approaches, such as this one. This is one approach. Factoring is one approach. The approach of sine alpha over alpha as the limit of alpha approaches 0 equals 1. That's also one approach if it involves trigonometric function. Pero, naisip mo na tong mga approaches na to at hindi siya nag-work, that's the time that you apply L Hupital's rule. Okay? L Hupital's rule, this is what it says. The limit of f of x over g of x as x approaches a is equal to the limit of the first derivative of x over the first derivative of g of x as x approaches a. This means you get the first derivative of the numerator. You also have to perform or obtain the first derivative of the denominator separately for you to be able to evaluate this. But there are some conditions. It is important that you verify the conditions regarding the limits of f and g before doing or using this rule. The rule is only valid for one-sided limits and for limits at infinity or negative infinity. Okay? It also works for as x approaches a from the positive side, x approaches a from the negative side, as x approaches infinity, as x approaches negative infinity. It works. No? You can use this kahit na x over a lang yan, or kahit na x approaches a lang yan. It also works for x approaches a positive side, x approaches a negative. Ito yun. This is what it means. For the special case in which f of a is equal to g of a equals 0, f prime and g prime are continuous and g prime of a is equal to 0. So, dapat din masatisfy mo. Ito yung mga notations na dapat mong tandaan, no? So, pero, class, ito talaga yung LHR. Example, apply natin to kanina, no? The limit of ln of x as x approaches 1 for this expression, ln of x over x minus 1. Take note, this is 0 over 0. And so, applying L Hupitas Rule, we derive the numerator. Derivative of numerator is ln of x. 1 over x. This is the derivative. Derivative of the denominator is 1. And so, applying the limit, we have 1 over 1, which is 1, and then over 1, so the answer is 1. So, kanina, we have this, kasi we cannot factor this. We cannot apply yung mga argument that approaches infinity because this is x approaches 1. Hindi naman siya argument approaching infinity. So, we cannot apply those strategies. Kaya, ang option talaga natin is LHR to evaluate this limit. And we have an answer. It is equal to 1. Another example, find the limit of e to the x divided by x squared as x approaches infinity. So if you're going to evaluate this, e to the infinity is infinity. Infinity squared is also infinity. So it is of the form infinity over infinity. Hindi mo naman pwedeng gawin na yung argument that approaches infinity wherein you're going to divide this by the exponent, the variable of the high exponent. Hindi naman pwede eh. Yan. Diba? So kung gawin mo yan, you have an answer na e to the infinity over 1. So mangyari pa din, infinity over infinity pa rin siya kung ganyan ang approach mo. Kaya ito, apply natin L Hupitas Rule. So get the first derivative of e to the x. The derivative is e to the x. Derivative of x squared, 2x. Now, evaluate ulit. E to the x, as x approaches infinity, is infinity. 2 times infinity, infinity pa din. So, since infinity over infinity pa din siya, we can apply the L Hupitas Rule the second time. So, pwede pa lang second time, third time, and so on. So, applying the second time, what's the limit of e to the x? It still is e to the x. What's the limit or derivative? What's the derivative of 2x? The answer is 2. So, you now have the limit as the limit of e to the x over 2 as x approaches infinity. When you replace or evaluate this limit, we have e to the infinity divided by 2. So, that means e is a constant number raised to a very, very huge number, unbounded. So the answer is infinity over 2. Now, irrelevant na yung divisor na yan because this is unbounded. So therefore, the answer is infinity. Nakuha niyo, class? Now, okay, another one. Find ln of x divided by the cube root of x as x approaches infinity. Again, you test. Ln of infinity is infinity. What is infinity raised to 1 cube? 1/3. The answer is still infinity. Okay. So this is of the form infinity over infinity. Now let's apply L Hupitas Rule. What is the derivative of ln of x? Derivative is 1 over x. What's the derivative? What's the derivative of x to the 1/3? Derivative of that is 1/3. 1/3 minus 1. So we have 1/3 of x to the 2/3. Okay, negative. That's why we have it here. Simplifying this, we now have the limit as x approaches infinity. Now, what is the limit here? numerator natin is, if we apply 1 over infinity, this is 0. Then we have 1/3 of 1 over x to the 2-fifth. 2-fifth. 2/3. 2/3. Still, this is 0 kasi 1 over infinity is 0. So this is 0 over 0. From infinity over infinity, naging 0 over 0. Still, indeterminate pa rin siya. So what we're going to do is to apply L Hupitas Rule the second time. So applying L Hupitas Rule the second time, we write derivative of 1 over x is, ano class? So derivative of that one. Negative
1 over x squared.
Yes, negative 1 over x squared. Kasi ito magiging negative 1 minus 1. Kaya ito, yung pangalawa, yung denominator. So, meron tayong 1/3 dyan. X to the negative 2/3. The derivative of that is, so parang you will see na kahit anong gawin mo, ay magiging 0 over 0 pa rin siya. Tama? Tinitingnan ko lang kung anong magiging reaction nyo as we proceed. Notice na, class, na dito pa lang, pwede ka nang hindi mag-L Hupitas Rule. Pinakita ko lang sa inyo na if you proceed to applying L Hupitas Rule, nagiging ganun pa din. So why not na dito pa lang, sa expression na to, na meron tayong ganito, ayan, pwede mo namang gamitan yan ng natutunan nyo sa rational expression. How about try to investigate ito? Itong 1 over x. Ito plus. If you isolate that one, 1/3, x to the negative 2/3. Diba, this can be also written as, meron kang, diba, reciprocal of this. What's the reciprocal of this one? What reciprocal of 1/3 is 3. The reciprocal of x to the negative 2/3 is 2/3. Diba? So, you can evaluate this as 3x to the 2/3. Tapos yung 1 over x, you can write that as negative 1. Using law of exponent, that could be 3x 2/3 minus 1, or 2/3 minus 3 over 3. That gives you negative 1/3, right? Or 3 raised to x to the 1/3. If you apply the limit, if you apply the limit as x approaches infinity, take note that you now have an expression 3 over infinity. Remember, any number divided by infinity is 0. So therefore, the answer is 0. Say for example, you encounter this one. Find the limit of x ln of x as x approaches 0 from the positive side. You cannot apply L Hupitas Rule here because you can only apply LHR if it is of the form 0 over 0 or infinity over infinity. Which means you have to convert this into a rational expression. You may opt to rewrite this as ln of x over 1 over x. That is still x times ln of x. Or you may also write If you use this one, if you evaluate what is ln of 0, that is equivalent to ln of 0 is what? From the positive side. What happens to ln of x? When your x, say ln of 0.001, what is ln of 0.0001? Meaning, you're approaching 0 from the right. What is the trend? Ano kas? Use your calculator. What is the value here? Is it increasing, decreasing, or is it 0?
It's decreasing po.
It is decreasing. Are you sure? What is ln of 0.1? What is the value of ln of 0.001? Give me the value.
Negative 6.90.
Okay, what's the value of ln of 0.00001? The value is decreasing. Pagka mas malapit na malapit yan sa 0, anong mangyari? It approaches infinity. Negative infinity actually. Now, what is the value of 1 over x? As your x approaches 0. What is 1 over, let's say, 0.01? You compare that with 1.0001. What is the trend? Ganyan kayo mag-evaluate class para malaman nyo kung ano yung mali. So, as x approaches 0 from the positive side,
Increasing naman po.
increasing naman siya ngayon. So, meaning, itong expression na to is of the form infinity over infinity. Okay. Yan siya, no? So, may dalawa kang option, as I have said. If you have if you take this, you have 0 over 0 naman. Ito siya, infinity over infinity. So, saan dyan ang pwede nyo maging approach? Yung 1 o yung 2? Diba mas madali? Is your option? Or which one would you choose? Deriving the first expression or the second?
First po.
The first one. Okay, very good. We use the first one kasi mas madaling mag-derive nito. What's the derivative of ln of x? Equals 1 over x. What's the derivative of 1 over x? We know already it's negative 1 over x squared. Ito mahirap kasi what's the derivative of 1 over ln of x? Di ba? Mas lalong maging complicated yan. So rather than choosing this one, mas prefer mo to kasi ito, if you are going to choose this, it gets more complicated. So let's apply LHR and see kung ano yung magiging value nito. Ano ba ang limiting value ng ln of x as x approaches 0? So we have converted it to from the limit of ln of x times x as x approaches 0. Nire-write natin siya into ln of x over 1 over x as x approaches 0. And apply LHR. So we get the derivative now of ln of x, which is 1 over x. Then derivative of 1 over x is negative 1 over x squared. Okay? Now let's proceed. Let's test again. Do we have an answer? Is it still 0 over 0? But wait, pagaya ng approach kanina, pwede nating i-simplify ito. This one, we can write it as 1 over x times the reciprocal, which is negative x squared. Diba? Instead of having a division, we will rewrite it to multiplication, but the reciprocal of the denominator. Plus, so this one, we can we can simplify kasi ito, cancel yan eh. So we have negative
X.
x. Okay? And the answer is, for this limit, the answer is
0.
0. Yun. That's how you will investigate this type of expression. That's how you apply yung indeterminate form of this type. The limit as x approaches 0 of x cotangent of x. What do you think is the answer? This is of the form 0 times infinity. Why is that? Because your x will be replaced with 0 and cotangent actually, class. Ano yung cotangent na expression? Cotangent is inverse of a tangent, which is cosine of x over sine of x. So, ibig sabihin, as your x approaches 0 dito, so, kasi ito magiging 1. Pero as x approaches 0, as x approaches a value of very, very small, di ba? A number divided by, ginawa na natin yan dito. Infinity yung sagot nyo. So this would be equal to infinity. Kaya meron tayong 0 times infinity. So indeterminate siya. We will rewrite this to a rational expression. Dapat P over Q. Para we can have 0 over 0 or infinity over infinity. That is when we can apply LHR. Hindi pwedeng diretso. So, might as well write x, cotangent of x over 1 over x, or mamimili ka na naman. You may have x over 1 over cotangent. But you know 1 over cotangent is equal to tangent. So maybe you can write, instead of 1 over cotangent, you write tangent of x. So which one? Yung ito? Or this one?
One po.
So choose expression 1. Okay. What's the derivative of cotangent of x? The derivative of 1 over x. We know already this is 1 over x squared. It's the derivative of cotangent.
Negative cosecant squared x.
Yun. Negative cosecant squared of x. Okay. Ano nga ba yung cosecant? Cosecant of x is 1 over sine, right? Now, let's validate kung may sagot na ba tayo dito. Of cosecant squared of x as x approaches 0 of negative 1 over x squared. Which you can, by the way, rewrite as negative sine squared of x. Negative. Times natin ng x squared. Kasi reciprocal nito. So negative. Negative and negative becomes positive. Let's apply the value of the limit. What do we have? We have denominator, the answer is 0. Still, it's 0 over 0. Di ba, class? Terminate, para ano ang gagawin? Ha?
Mag-L Hospital.
Mag-LHR ulit. So, dito tayo. Apply LHR. Second time. So, the derivative, diretso na tayo ha. The limit as x approaches 0. The derivative of numerator is 2x. Derivative of the denominator is 2 sine of x times the derivative of sine, which is cosine of x. Now, the answer is still, cancel mo yan. Cosine of x or cosine of 0 is 1. But then sine of 0 is 0. Still, so ang tagal. Kaya itong choice na to ay perhaps para sa nakita na natin ngayon, medyo pag nakita mo tong trend na yan habang nagsosolve ka, tigil ka na. You stop and consider number 2. Perhaps number 2 is better than number 1. Because if you derive your x, you have an answer na 1. Saan dito sa 2. Derivative of x equals 1. What's the derivative of tangent of x? What's the derivative of tangent?
Second squared x.
Second squared of x. But what is second? Second is 1 over cosine squared of x. Diba? So therefore, itong number 2, we can write it after applying L Hupitas Rule. Magiging ganito na siya. The limit as x approaches 0 of 1 over cosine squared of x. Now take note that if you apply now the limit of 0 as x approaches 0, this will be equal to what? What is cosine of 0?
1.
1. Therefore, you now have an answer which is equal to 1. So what I'm showing you here is, for this type, you have to be very careful because you have two options. Either the first term, you will make it as the denominator, or the second term as the denominator. Ano pang mga indeterminate forms natin? Tapos na tayo sa 0 over 0. Nagbigay na ako ng example ng infinity over infinity. We have 0 times infinity. Let's take up infinity minus infinity. Because the other forms that, let's say for example, find or evaluate as x approaches infinity, 0, from the positive side of 1 over x minus 1 over sine of x. So you will notice that this is of the form 1 over 0 from the positive side. 1 over 0 from the positive side, class, is infinity. So this is infinity minus infinity. So what we're going to do is to find LCD. Para isang fraction lang siya. So finding the LCD, we have x sine of x of sine of x minus x, or sine of x. Now, we evaluate. Is this already of the form 0 over 0? Because if not, di natin pwedeng i-apply ang L Hupitas Rule. Now, this is definitely of the form 0 over 0. Diba? Obvious naman. Okay? So, get the first derivative. What's the derivative of sine of x minus x? Derivative of that is
Cos x minus 1.
cosine of x minus 1. Very good. Derivative of x sine of x. That is using product rule. Right? So, first siguro, derive natin yung x, which is 1 times sine of x plus x naman, derivative ng sine cosine of
X.
okay. So now we can now equate this to the limit as x sine of x and evaluate now as your x approaches 0 minus 1. Sine of 0 is 0 plus 0 times 1, right? Tama? Diba? So 0, negative 1 over 0 siya. Ano, sorry. Yeah. Cosine of 0. Cosine of 0 is 1. Mali tayo doon. So, ibig sabihin, this is of the form, ano,
Indeterminate.
0 over 0 pa rin, plus, no? Diba? Tama?
Yes po.
Yes. So, huwag lang magsawa. Apply ulit. Ganun lang siya. Tsaga-tsaga lang. So, we have, what's the derivative again? What's the derivative of cosine of x minus 1? Derivative is
Negative sine
negative
X.
sine of x. Wala na yung 1. No? What's the derivative of sine of x plus x cosine of x?
2 cos X minus X times sine X.
Cosine of x plus, ito power rule to, product rule. Diba? Plus, tama yung sinabi mo. 2 cosine of x minus x sine of x. Okay. So, we now have a limit as x approaches 0 from the positive side. Ang numerator natin is negative sine of x. Ang denominator natin is we have 2 cosine of x minus x sine of x now. Anong nangyari na yan? What is the answer? This will approach the value of 0. This will approach a value of 2. This will approach a value of 0. So we have an answer 0 over 2. Or the answer is
0.
0. Okay, so do you have questions, class? Sa susunod na natin i-discuss yung remaining